Hey everyone, welcome to Simplilearn's YouTube channel. In this tutorial, we will learn what exactly are web neural networks. Before that, let's take a look at web neural networks and all the hype about it. Imagine running powerful AI models right in your browser, no cloud, no delays, just pure speed. That's exactly what web neural networks bring to the table. It taps into your device's GPU, NPU, or AI accelerators to run machine learning models locally, making things faster, smoother, and way more private. For developers, this means no more waiting on cloud servers. Your AI features like image recognition, chatbots, and real-time analytics run instantly. It plays nicely with TensorFlo.JS, ONNX, and other machine learning tools, so integrating it is a breeze. And the best part, web apps are about to get way smarter. With web neural networks, AI features will feel as snappy as native apps, pushing the limits of what's possible in web development. That is the future of AI on web, and it's happening now. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. And also, just that you know, if you want to upskill yourself, master generative AI and artificial intelligence skills and land your dream job or grow in your career, then you must explore Simplilearn's cohort of various generative AI courses and certifications. Simplilearn offers various certification programs in collaboration with some of the world's leading universities. Through our courses, you will gain knowledge and work-ready expertise in skills like advanced Python, machine learning, generative AI, and over a dozen others. That's not all, you also get the opportunity to work on multiple projects and learn from industry experts working in top-tier data and product companies, and also academics from top universities. After completing these courses, thousands of learners have transitioned into an AI and machine learning role as a fresher or moved on to a higher paying job and profile. If you are passionate about making your career in this field, then make sure to check out the link in the pinned comment and description box below to find a generative AI program that fits your experience and areas of interest. Now, without further delay, let's get started with web neural networks. So, this will be the agenda for today's session. First, we will understand what exactly is a website. Let's start from the scratch. Then, average time that we spend on an actual website, or average time spent on developing an exact website, and some bottlenecks of website, right? Some of the problems that you might be facing while developing or spending time on website, just reading some blog or anything like that. And then, after understanding the problems that we are facing or the pros and cons of the traditional way of web development, we will dive into the web neural networks. After that, we will understand how exactly web neural network works and the hardware and software specifications that you will be needing locally on your computer system to run web neural networks. And lastly, we have one question for the people who are really curious about web neural networks. Is it going to replace the traditional web development methods or not? So we'll also take a look into that as well. Now, let's get started from the fundamentals. What exactly is a website? So, basically, a website is a collection of interlinked web pages that are accessible via internet. Websites can be static, displaying fixed content, or dynamic, which can update the content based on your user interaction and backend processing. So, internet and the websites have become the major resources of information and knowledge. So, they are now globally accepted, right? And apart from that, let's go with the next step, the average time spent on websites. So, as discussed, websites have become the major medium for information access globally. Users rely on websites for knowledge, decision making, and research. Search engines have boosted website accessibility, making it easy for users to find relevant content. And apart from that, studies show that average internet users spend about 6 to 7 hours daily on websites for various activities such as social media, research, entertainment, and shopping. Now, there are three different types of websites: basic websites, e-commerce, and enterprise. Now, let's understand each one of these. So, what exactly is a basic website? So, it can be a personal blog or a small business site. An audience spend about few hours, right? And to build these websites, one can take about a couple of hours, or based on the complexity, maybe even a couple of days. Now, moving ahead, we have e-commerce websites. So these e-commerce websites like Shopify, WooCommerce, Amazon, etc., So major audience spend their time on these type of websites, and to build and maintain such websites, it might be a little too difficult compared to a basic website. It might take a few weeks, months for customization and integrations of additional AI tools, something like that, right? And lastly, come the enterprise websites. These are the completely customized type of websites which are built for enterprises or some companies. And these type of websites might take several months to a year, involving backend databases and integrations of AI if necessary, right? So now this is where the web neural networks come into the picture. Let's say now, generative AI is also globally accepted and it is also really trending. Let's say if there is an opportunity where you can integrate AI with your web development procedures to enhance your capabilities and improvise the experience of user, right? It sounds interesting. Now, let's say what happens if AI can be integrated in web development? How can AI improvise web development is the question of our. So there will be some good improvements, starting with speeding up the development process. AI powers up coding assistants like GitHub Copilot, which automates repetitive coding tasks. And moving ahead, we have enhanced performance. Web neural networks leverage local hardwares, which are the GPUs and CPUs, for real-time AI computations, reducing server dependency. Third one is improving user interface and user experience. AI-driven personalization adapts websites to user behavior for a smoother experience. And next ahead we have boosting the SEO and accessibility. This is the major part. AI tools optimize content for search engines and provide features like voice search. And lastly, strengthening security. AI-driven security systems detect and mitigate cyber threats in real time. Now, these are the overall advantages that AI can bring to the table in web development process. Now, let's understand what exactly is web neural networks. Now that we have a basic understanding of what is web development, what is a website, and what happens if you integrate AI or generative AI with your website development process. Now, web neural networks, or commonly known as WebNN, is a JavaScript API. Mentioned again, it's just an API which is designed to facilitate the use of neural networks within web applications. It provides a standardized interface for running computationally intensive machine learning models directly in the browser, enabling developers to build and deploy AI powered features without relying on server side processing. Now, let's also discuss some of the key features of WebNN. Firstly, standardized API. It offers a consistent interface for various hardware accelerators, ensuring compatibility across different devices and platforms. Second one, performance optimization. It leverages hardware capabilities like GPUs and specialized machine learning accelerators to enhance the performance of neural network computations in the browser. And lastly, privacy and security. By processing data locally, web neural networks help in maintaining user privacy and reducing latency associated with network requests. Now, let's go through some casual use cases. Firstly, real time image and video processing. Implementing features such as object detection, face recognition, and augmented reality directly on the browser without having to wait for your servers. Next is natural language processing. Remember about the discussion of integrating voice recognition in your browsers? That's about it. Enabling applications like chatbots, translators, and sentiment analysis tools without server dependencies. And lastly, personalized user experiences. Delivering adaptive content and recommendations based on user interactions processed in real time. So you have a lot of options on Instagram these days, right? Based on your requests or based on your preferences, your content is organized. That's about it. For a comprehensive understanding, you can also go through some official documentations on web neural networks. Now, proceeding ahead, we will discuss some of the hardware and software specifications that you need to have on your local computer to run WebNNs. So, let's begin with hardware. The first one, processor. A minimum of 12th generation Intel Core processor is required, with optimal performance achieved on the latest Ultra processors. The next is the graphics processing unit, or also GPU. So for GPU acceleration, ensure your system has a compatible GPU and that has the latest drivers installed. And lastly, the natural processing unit. On systems equipped with NPUs such as Intel Core Ultra processors with Intel AI Boost, web neural networks can offload computations to these specialized units for improved efficiency. Now, let's proceed with the software requirements. So basically, the software requirements will be an operating system and a browser. So beginning with the first one, which is operating system, Windows 11 version 21 H2 or later is necessary to support web neural network functionalities. And coming to the web browser, a Chromium-based web browser is required for GPU support. The most recent version of Microsoft Edge Beta is recommended. Now let's also go through the quick setup requirements. So you need to install a compatible browser first, download and install the latest version of Microsoft Edge Beta or Canary, or depending on your hardware configuration, you can proceed with the one you would like to choose. Next ahead is you need to enable Web Neural Networks API. In the browser's address bar, navigate to About Flags. I was supposed to highlight it, so here you can see About :flags. You need to go to this particular location, search for WebNN API and set it enabled. Restart your browser as prompted and you're good to go. Next, verify hardware acceleration. Ensure that your system's GPU or natural language processing unit drivers are up to date to fully leverage hardware acceleration features. By adhering to all these hardware and software specifications, developers can effectively integrate and utilize WebNN in their web applications. Now, let's dive further and understand how exactly the web neural networks work. So basically, as discussed before, Web Neural Network is a JavaScript API that allows web applications to run machine learning models efficiently within the browser by leveraging hardware acceleration using the GPU, natural language processing units, and AI processors. So some of the key steps in WebNN execution are as follows. Firstly, the model preparation. Pre-trained machine learning models, for example, TensorFlo.JS, ONNX models are used, and models are optimized for web neural network executions. Next is hardware acceleration selection. Web neural networks detect the available hardware, the CPU, the GPU, the NPU, and selects the best option for execution. And it also uses DirectML on Windows, Metal on macOS, and other APIs for performance optimization. The third stage is execution pipeline. It takes inputs, which are the images, text, audio, and these are fed into the neural network model. WebNN processes the input using optimized computations. And lastly, the model outputs predictions, classifications, and transformations. Moving ahead, we have the fourth stage, which is integration with web apps. The results are displayed using JavaScript and DOM manipulation and can be combined with WebAssembly, or also known as WASM as an acronym, for further performance enhancements. Now, let's discuss the key benefits of web neural networks. So, the four major benefits of web neural networks are as follows. Firstly, the speed. Faster machine learning model execution by using the GPU and NPU accelerations. Second is privacy. No need to send sensitive data to a server. Everything runs locally on your own browser. Reduced latency is the third one. AI computations happen in real time directly in the browser. And lastly, cross-platform. Works across different browsers and operating systems with proper hardware support. Now proceeding ahead, we will learn the question which we had. Is web neural network really replacing traditional web development frameworks, tools, and procedures? So the answer is straight ahead. It is a big no. Web neural network is not replacing traditional web development frameworks or tools or languages. Instead, it complements them by enabling efficient on-device machine learning in web applications. So here is a breakdown of why web neural network is not a replacement but an enhancement. So firstly, it will replace or reduce dependency. So let's discuss with the first one. Cloud-based AI model processing. Before web neural networks, web apps had to send data to the cloud-based AI servers like Google Cloud AI, AWS SageMaker, OpenAI, etc. to process the machine learning models. With web neural networks, many AI models can now run directly in the browser using local hardware acceleration, which are the GPUs and NPUs, reducing the dependency on a cloud, and it impacts lower latency, better privacy, reduced server costs. Now, the second one is WebAssembly and TensorFlo.JS for machine learning tasks. Before web neural networks, TensorFlo.JS or TFJS and WebAssembly were used to run AI models in the browser, but performance was limited. With web neural networks, it provides direct access to hardware acceleration, improving speed and efficiency over TF.js for certain workloads. Impact again, web neural networks may replace TensorFlo.js for performance critical applications but won't fully eliminate it. And now, lastly, server side machine learning processing for certain use cases. Before web neural networks, web apps had to rely on Python based machine learning stacks, for example, TensorFlow, PyTorch on the server. Now, with web neural networks, many machine learning models, which include image recognition, NLP, etc., can now run locally in the browser, reducing the need for backend machine learning server. Again, the impact: faster response times, improved user privacy, but heavy models may still require backend processing in very rare situations. Now, let's take a look exactly on what are the things which has dependency. Now, the traditional front-end frameworks like Angular, Vue.js, ReactJS, etc., these are not going to replace. Web neural network is not a UI framework. It works alongside the front-end tools to bring machine learning capabilities to the web apps. Example, you can use web neural networks inside React app to apply AI-powered image enhancements without replacing React itself. Second one, backend databases and APIs. Web neural network processes machine learning in a browser but does not replace databases, authentication systems, or any APIs. Web apps will still need a backend for user management, data storage, and business logic. And lastly, server side AI for large machine learning models. While web neural networks is great for learning small to medium sized machine learning models in the browser, complex AI tasks, for example, deep learning on large data sets, will still require cloud GPUs or TPUs. Example, ChatGPT like models are too large to run entirely in a browser, so they still rely on backend processing. Now, to make things clearer, I've arranged a table. So here you can see the components: user interface development, AI execution, performance, privacy, server dependence. Let's start with the first one. UI development. Before web neural networks, React, Angular, Vue were the common ones. And after web neural networks, we will be using the same frameworks as well. For AI executions, cloud-based AI, TensorFlo.js, WASM, right? Now, the only difference is you don't have to rely on these cloud or servers for small or mid-sized applications. You can run them directly on the local browser. That's one enhancement. And performance. CPU and heavy JS libraries. Now they are replaced with graphical processing units and natural language processing units for acceleration. Privacy, data is sent to the servers. Again, it is similar to the second point. So now here you don't have to rely on the service every time. You can just run the application locally on your browser without having to depend on the servers, and it also kind of improves privacy and security. And lastly, the server dependence. Backend machine learning servers are needed back in the days. Some tasks, right, based on the size of the application, if it's small or mid-size, you can run it locally. But if it's bigger, like ChatGPT and deep learning models or bigger datasets, as we discussed before, you will anyway require a server in the backend. So these are the critical differences. on before and after web neural networks. And that brings us to the end of this session on web neural networks. If you have any queries regarding any of the topics covered in this session, or if you require the resources like the PowerPoint presentation that we used in the session, or additional information on web neural networks, then please feel free to let us know in the comment section below, and our team of experts will be happy to assist you at the earliest. Until next time, thank you for watching and stay tuned for more from Simplilearn.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.